in this webinar series, we are continuing on with our Summer of 6E as we take a deep dive into 6 gigahertz Wi-Fi and beyond.
Here we are. So you probably know Matt and I, directors of ECSC in product marketing. You know Dale. He joins us very frequently. And I'm pretty sure that almost, if not everyone, knows David Coleman, a director of wireless networking, office of the CTO at Extreme Networks. David, thank you very much for donating your time to join us today. We are extremely, extremely honored by your presence. How are you doing today, my friend?
I'm doing great, fellas. Thanks for having me. It's my pleasure to be here and see. It's really cool seeing how you guys have everybody identify where they're from and seeing people from all over the world tuning into this webinar. So it's actually my pleasure to be here.
Oh.
The pleasure is all ours.
Yeah. So
guys, by the way, do you guys still call yourselves the Wi-Fi ninjas?
I think they sometimes call us the Ekahau ninjas now.
So you're the Ekahau ninjas now. Okay.
Yeah,
outstanding.
I'm sure people probably call us a lot worse. So we're happy with either, to be honest. But before we kick off today, we wanted to make a quick announcement that we have got our Wi-Fi day back this year, and it's going to be on September 15th. So you can register early for a great day of content all around Wi-Fi. So it's a fantastic event. If you want to get signed up early, make sure you block out that time on your calendar. You can pull out your phone, scan that QR code, and you can make sure you get yourselves registered. And to kick off today, we wanted to talk about how, how Wi-Fi has changed how we do things in today's world. And it's now even more business critical than it has ever been before. There are something along the lines of 700+ million Wi-Fi networks out there. And if all of these Wi-Fi networks were designed, validated, and then regularly health checked by everybody on this call, then everywhere we went, we would have amazing Wi-Fi. But we know that just unfortunately, that isn't the case. And in most situations, a lot of these Wi-Fi networks, they were never designed properly. So they were never validated properly. And then they were never regularly health checked. And that's why we have such poor experience when we go to some of these venues around the Wi-Fi. And one of the most typical solutions we see people try to adopt when it comes to troubleshooting their Wi-Fi designs or their Wi-Fi networks is they think, hey, actually, why don't I just throw some more access points in here? That will fix my Wi-Fi problems. When actually just throwing more APs at a deployment can sometimes make the Wi-Fi even worse. It's a really interesting conversation, a funny conversation to have with the stakeholder when you say to them, hey, if you want more Wi-Fi, you need less access points. And they sit there and they go, how does that work? And you said, yeah, that is right. If you want more Wi-Fi, you need less access points because there's just too much contention and it wasn't designed properly. And one of the big things that we see is that there's just really not enough detail paid after the deployment. So no validation and then no regular health checks. And what we know is that environments change. Offices have been reconfigured. The way we use Wi-Fi has changed. More people in a hybrid solution. Some people are in the office, some people at home, some people are joining from a meeting that they are on site. Your warehouse has had a reconfiguration of the racks. You've got different amount of stocks in your racks. So everything has changed. So it's really key and important that you do those regular health check surveys to make sure that your environment stays high performing for your Wi-Fi network.
But sometimes it really doesn't matter what you do. If you want to have high-performing Wi-Fi, but you're limited to use 2.4 gigahertz, it's not going to work, especially in higher density, especially if you have more neighbors. Because in 2.4 gigahertz, we have just 3 non-overlapping channels, at least in the US. And since we are copying everything that our American friends are doing globally, we are using 3 channels as well, even though we have 4 and Japan might have even more. So 2.4 gigahertz has around 60 megahertz of usable spectrum. It's like 100 megs, but we are using 60 practically. Now on 5 gigahertz, we have around 25 non-overlapping channels. And on 5 gigahertz, we can have more radios operating at the same time, hearing each other with clients connected to each of those APs, not having to contend for the airtime. So we can have lower latency, higher throughput applications that are more critical for us today. So voice and video in office environment is not unusual to run on Wi-Fi. But now with more applications coming, AR, VR, and you will see it is coming. It's not something that we use for fancy marketing terms. It's a real thing. We need to have more spectrum, right? You need more spectrum, and that's where 6 gigahertz comes in. So David, why won't you talk us through high level about why 6 gigahertz is such a great deal?
Thanks, fellas. So absolutely. So let me put it this way. I'm getting up there in years, and I was actually considering retiring soon, and I've kind of put that off. And one of the reasons, and in all seriousness, is because of the availability of 6 gigahertz for Wi-Fi, and how excited I am about it. It's the biggest thing to happen to Wi-Fi, I think, in about 15 years. The last paradigm shift that I think that was this big was probably in 2009, probably then, when we went to 802.11n, when we went from CISO radios to MIMO radios, when we went from when multipath was our enemy to actually it became our friend.
Sorry, David, what is your Twitter handle?
It's at Mr. Multipath. Yeah. Oh, yeah. So there you go. Nice plug there. So thank you, my friend. Caught me off by surprise there, but thank you. But that being said, that was the last really big paradigm shift and shot in the arm for Wi-Fi, and Wi-Fi really took off in the enterprise and all kinds of verticals back in 2009. And I think we're getting ready to see a same kind of renaissance and huge economic boom due to the availability of the 6 gigahertz spectrum. As a matter of fact, if you go back in history and look, whenever you open up unlicensed frequency bands for use for Wi-Fi, it's been proven time and time again that the economic value is nothing short of billions of dollars. And that's why it happened starting in the United States and now moving into other countries. 1,200 megahertz of frequency space available in the United States and other countries. In Europe, it's only 480 megahertz of frequency space that is available, at least initially, in the Uni-5 band. But you never know, the regulatory bodies might take a second look at this down the road and even open up more frequency space. It's actually happening faster than we thought it would. I think there's something like 60 countries that have adopted or thinking of adopting all or portions of the 6 gigahertz band to be used for Wi-Fi. Now, to the original question about why this is a big deal, this frequency has never been used for Wi-Fi before. So you're getting a frequency space that is literally double the size of 2.4 and 5 gigahertz combined. For indoor use, you don't have to worry about a lot of RF interference like microwave ovens and things like that. But the other thing is there's no backward compatibility. I just got done writing a blog about how backward compatibility is a double-edged sword. It allows us to hang on to old legacy devices, but the problem is the old legacy devices drag everybody down. We don't have to deal with that in the protection mechanisms that we have in the legacy bands. And so think of this as like, it's like the wild, wild west of spectrum, but it's for Wi-Fi. And just to summarize real quick, I think on the value of this, I think it's going to drive innovation for applications. You mentioned VR and AR. Yes, that is sometimes marketing hype, but we're actually going to see a renaissance of innovation for applications using those technologies, and we're going to need 6 gigahertz for that. Because for the bandwidth and the latency requirements. And I also think, go ahead.
No, I was going to say, David, I think one of my favorite sayings, I'm not sure if it's your saying or if you borrowed it from someone else, is that 6 gigahertz is like Wi-Fi being born again, getting this much of a new additional spectrum to be able to use.
Yeah, and I encourage everybody to steal that statement because I stole it from our product director, Rosalie Babano at Extreme Networks, and it's true. It really is like Wi-Fi is being born again. And I also, look, Ekahau is, what do you guys do? I mean, you're a design and a troubleshooting and a validation solutions, right? That's what you make, right? And you know that 6 gigahertz is really starting to hit the big time when those tools that are available for that have 6 gigahertz capabilities in it. And you guys have built that into your products now. And I would like just to kick off this whole webinar, like to challenge everybody on this call to come up with creative ways to design, and new ways to design Wi-Fi networks using this spectrum, because there's so much. It could be something as simple as just moving certain applications to 6 gigahertz and keeping them off of 5 or 6, or it could be using 6 gigahertz for density and 5 gigahertz for roaming. Or it could be maybe even using different chunks of the spectrum for different particular things. So you guys out in the field, I mean, I know, I have no doubt that using Ekahau products, you'll come up with new and creative things to do with 6 gigahertz.
Okay, so David, you are talking about 1.2 gigahertz of available spectrum in the US. But my question is, do all the devices and all the access points, do they use all available 6 gigahertz spectrum? Because I can see something that is called low power indoor. Let me switch to the next slide. We have something also called standard power. What's the difference between them two?
Well, that's more to do, well, it's due partially to the spectrum, but it's also due to power rules. And so initially, Wi-Fi 60 and 6 gigahertz is an indoor play only, using what are called LPI, low power indoor power rules, and that are very specific for APs and as well as clients. And what that is all about is you can use Wi-Fi indoors, but you can't use it outdoors. That's what standard power is about. I'll circle back to that in just a second. And the APs that are being manufactured, and we have an AP 4000 and 5010 that we're already selling and deploying in Europe and all over the rest of the world as well. It can only be deployed indoors. It even has a sticker that says for indoor use only. And the reason is there are incumbents that operate and specifically outdoors and like fixed satellite services. And we don't want to interfere with them. And it's already been proven with a lot of research that the indoor rules won't cause any problems. But outdoors, we're limited on what bands we can use. We can only use Uni 5 and Uni 7. We can use this higher power, standard power, and we can use external antennas, and we can use weatherized enclosures. Now, this is dependent on something called AFC that I believe we're talking about later on in the webinar. But that being said, initially 6 gigahertz is an indoor play, but we'll have outdoor use available starting in the United States and then following with other countries starting in 2023.
Okay, so low power indoor has around 59, well, it has 59 exactly 20 megahertz wide channels, and standard power has slightly less, 41 channels to protect the incumbents, but there are different power rules and different rules that they have to abide. We will talk about these rules in a sec. So these are the different classes of the devices. So we have talked about the LPI and SP a little bit. Shall we talk a little bit more about the fuller picture of this picture?
Yeah, so I'd like to hit a lot of points here. So once again, you can actually see there's actual different power rules for LPI and standard power. And as you pointed out, you can only use about half the frequency space as well for standard power. There's chunks that you just cannot use. Although, and by the way, I also want to say standard power is meant to be used outdoors, but we're also figuring out that that there are going to be some potential use cases for standard power indoors in the future. So
what's the benefit, David, of using SP indoor? Why do we need more power? Would clients be able to match that power?
Well, there's a lot of things. That's one is for clients have, it's a big part of it is so having clients have higher power, and clients with standard power will have higher power. So we're finding some situations with low power indoor clients that we're having kind of a power mismatch between APs and clients, and having higher powered clients indoor. There might be some particular use cases, but it also has to do with other things like in warehouses and things like that, where you need weatherized enclosures, where you might be doing pressure washing, or you might need to use directional antennas or third-party antennas. You can't do that with LPI, but you could do that with standard power. So we've identified very specific verticals where standard power is going to be used indoors as well. But it will have to abide by the automated frequency coordination rules that we'll talk about in a few minutes.
Okay, that's quite fascinating. So David, just let me reiterate it quickly. LPI APs, they will not support external detachable antennas. Therefore, they will not be suitable to use for verticals like warehouses with high racks, where you do rely on those directional antennas that you typically connect externally to the access point with a slot for the antenna or slots for the antenna. You will have to use standard power. Now, a cheeky question. Is it possible to have a built-in directional antenna in LPI AP and use that in a warehouse to have more channels to use?
Yes, it is. It is possible to do that. It is possible to do that. So it's, I don't want to tip any, you will probably see vendors build such animals. Let me just put it that way, where there are fixed directional antennas on LPI APs. That is possible. I'm not saying that Extreme is going to build something like that or anybody else, but they just cannot be detached, and you cannot put third parties. I think you're going to see. Go ahead.
I was just going to say, and with the low power indoor as well, they can't be mobile. They have to be kind of, plugged in.
You right now you even have to be a sticker. Now I will say this, and we were talking about this before we went live. A lot of this is still in flux, and I think you might see some loosening and changes to the rules too. So I think you might actually see some. I'll come back to the clients here in a minute, but maybe in the future there might be a way to have a dual power APs. And what I mean, and no commitment to this, I'm just theorizing right now. What if we could start building APs that had standard power that you could then roll back to LPI power if you wanted, where you effectively get certifications for both. Things like that are under consideration. So
it's super interesting, all of this different device classification around the low power indoor, standard power, but not only just from thinking about it from the access point perspective, having to think about this from the client's perspective. Like, what if you're in a situation, David, where you deploy low power indoor access points, and then the consumer goes out and buys a standard power client device, and they go into that environment? Are they even going to be able to see the 6 gigahertz Wi-Fi network from this access point and connect to it?
So outstanding question. So I think what you're going to see is that most clients will actually be what are called dual clients. So because think about it, if hopefully let's pray that the iPhone 14 will be Wi-Fi 6E. We'll find out here in a couple of weeks.
Fingers crossed.
See if I can get Tim Cook. Call up Tim Cook. See if I can get some information. But if that happens, I mean, that would be terrible if you could only use it outdoors and you couldn't use it indoors, right? So that's why I think you will see the majority of the client devices, the good ones anyway, especially the mobile devices, the smartphones, be what are called dual client, where they can operate in either standard power or LPI power rules, depending on the scenario and where they're at. And we'll be seeing a lot of that.
Okay, so David, initially, tons of us, we thought that LPI would be the most popular device class, with standard power being a little bit, I don't know, too complicated, expensive to use for most applications. It will not be as popular as LPI. It clearly is not going to be the case from what you're saying now. So you think that smartphones will be dual clients, able to connect to both LPI and SP?
Mm-hmm. And once again, a lot of things are in flux, and vendors such as Extreme and our competitors, they're trying to figure out what they're going to do with their future Wi-Fi 6E APs, and quite frankly, their Wi-Fi 7 APs in the next couple of years. I think as AFC starts growing wider acceptance and the standard power rule regulations start falling into place, we'll start seeing more standard power capabilities will become more prevalent. Now, I will say this. We're not there yet. I mean, so there is no standard power yet. I mean, it's not even going to happen in the United States until my guess is late Q1, early Q2 of 2023, and then the rest of the world will probably follow. So we'll see. Maybe Brazil and Saudi Arabia, and hopefully Europe as well. But it's going to take some time. Now, if you don't mind, I'd like to just bring up some things about clients, if you guys don't mind, some real world things to think about. So
yeah, please do.
So one of the things that is, I think, been holding back 6 gigahertz is people have been telling me this. Where's the clients? Where are the clients? Well, guess what? You know how many clients there are now? It's really exploded in recent months. There are now, with 6 gigahertz radios, 61 models of smartphones, 633 models of laptops, and 21 smart TVs. So I need to get me a smart TV with 6 gigahertz. So see if I can. I'm going to put that in my expense report.
Well, David, I wouldn't mind having a 6 gigahertz AP first. I'm trying to buy one for a long time now.
Well, you can buy them. Extreme Networks will sell you we'll sell you LPI ones in Europe right now, and you can light them up right now. Now that being said, there's some weirdness with clients in the firmware, and let me explain that. So what we're finding is there's these new client detections methods that happen over the air to figure out what country the client device is in. It might use the emergency 911 capabilities of a smartphone over the cellular, or it might use 802.11d information where the clients are hearing it in beacon frames for nearby APs. And if 6 gigahertz is not available in that country yet, it'll just shut down the 6 gigahertz radios on the client phones. And so we've run into this. And despite us having Wi-Fi 6E and 6 gigahertz available stood up in Europe, we're finding that the client vendors haven't updated their firmware or their certification yet now in some cases. Now that's changing fast. So we're already getting reports that the Intel AX210 that's in most of the laptops has firmware upgrades, and we're getting connections in Europe and other parts of the world where it is legal to use 6 gigahertz now. By the way, the rules are still a little bit in flux there and could be tweaked a little bit. That being said, I'd like to request everybody on this is if you're getting 6 gigahertz connections in other countries besides the United States, do me a favor, make a screenshot on your smartphone or your laptop and send it to my friends here at Ekahau and send it to me via LinkedIn or Twitter. We're trying to keep up with that information, but there's other things that you should, real world aspects you consider as well. It's not an Apple product yet. Hopefully it will be very soon. On laptops, it's going to be Windows, right? Windows 11. Maybe a patch version of Windows 10. I think it's 21.2H patch, but Windows 11, you have some naturally stuff. But that being said, Windows is actually, Microsoft is doing some stupid stuff. And I'm not trying to call out Microsoft, but you know, WPA3 is a requirement in 6 gigahertz. And if you go into Microsoft and you try to configure WPA3 Enterprise, it tries to use 192-bit with ETLS. That's the only option, which is an optional option of WPA3. But if you want to use the standard WPA3, you actually have to configure WPA2. But it's what you're actually really doing in the operating system is configuring WPA3 because it uses the management frame protection. So there's going to be confusion is what I'm getting at. And so just be prepared. And a lot of it will be on the client side.
Yeah, and David, on the topic of confusion, when it comes to client devices discovering 6 gigahertz networks, I mean, that is something else that we have never really had to think about before, like in this kind of situation now with the 6 gigahertz band, and there being multiple different ways to discover 6 gigahertz wireless networks. So I was wondering if you could kick us off with the first one, which is the out of band reduced neighbor report option.
Yeah, so this is the most, when I talk to Wi-Fi geeks, which there's probably about 2,000 of them on this call, they have the hardest time wrapping their head around this because they're used to the AP discovery process for roaming by using probing, right? Meaning in band. Well, even despite some 3 or 4 optional methods of in-band discovery in 6 gigahertz. Those are all optional. And the only required and necessary and the most used method will be out of band, which is called reduced neighbor reports. And I think we have another slide that actually discusses this in a little bit more detail. So, what reduced neighbor reports does is basically this. The reason we don't do in-band scanning is there's too many channels, 6 gigahertz, and there's 59 20 megahertz channels, and you can only send probe requests on 20 megahertz channels. Now, tell me Matt, what do you think, or Mac, what do you think would happen if a phone scanned 59 20 megahertz channels probing?
Well,
time for a coffee.
I mean, if you were on a time-sensitive application, voice call, video call, and then your phone decided to go and scan all of the 6 gigahertz channels, your call would basically be dropped by the time it found that next access point to go and associate to and roam to, because it would just take far too long.
It would take far too long. It would probably cause disruption in application service, as well as probably missing APs to potentially roam to. And third, it's going to drain the battery life. The battery life of that phone is going to last about 30 minutes. So it has to, the primary method has to happen out of band. And all you're doing is leveraging probe requests and beacons out of band. So we'll use, it can happen in either 2.4 or 5, but we'll use 5 in this example right here. So there you have a smartphone that's probing on 5 gigahertz channels of 36, 40, and 44. They get responses back. They learn about those 5 gigahertz radios and their security settings and their other capabilities. But the APs also use this new information element called the reduced neighbor report to say, hey, 6E phone, what you should know. There's also a 6 gigahertz radio housed in this access point. And in this case, channels 53, 69, and 85. So you are actually relying on the fact that there's still going to be SSIDs on the legacy bands to advertise the 6 gigahertz information to the client so that they can find APs to potentially roam to.
Quick question, David. Can I use 2.4 gigahertz for out-of-band discovery to discover 6 gigahertz channels, for example?
Yes, you could, and it would actually be faster. It would, because you're only scanning 3 channels. But you know,
I have a follow-up question for you, David. Do I need to have the same SSID configured across 2.45 and 6 gigahertz to do the reduced neighbor reports, or can you have separate ones?
I get asked that question all the time, and it's an excellent question. The answer is no. You know, and as a matter of fact, due to the fact that WPA3 is required in 6 gigahertz and that WPA2 is still deployed in well over 95% of the legacy bands, we predict there will be different SSIDs used, at least in the short term, in 6 gigahertz than in the legacy bands. So it does not have to be the same SSID.
Okay, and Jeremy Baker is right on the chat. Stop doing the same SSIDs implementation on multiple bands at the same time.
Yeah,
exactly.
Yeah, I'm sorry, go ahead, Mac.
Before I jump to another thought, what did you want to say, David?
No, go ahead. Keep rolling. Okay. I'm having fun, man. So.
Oh, yeah, me too. Yeah, dying from excitement. So can you use like 8.11k neighbor report across 2, 4, and 5 to even quicker discover APs, radios on that band, and then ask them extremely fast about 6 gigahertz? Is that how it's going to work?
You know, look, vendors could probably use 802.11k and V to do creative stuff on their own, to develop their own weird features, like maybe some band steering capabilities, especially with 802.11b maybe. But that being said, I'm going to highly recommend that 802.11k be used in 6 gigahertz as well. Because look, those mechanisms like K and R, and to a certain extent V, they enhance roaming regardless of the band you're on, right? So, but using it particularly for discovery out of band, maybe for some proprietary stuff, but you know, any vendor can do things as long as they don't mess with the standards. They can do creative things.
Okay, cool. So let's take a look at the RNR information element inside the code. So what are we looking at, David?
So you're actually looking at a beacon. Actually, it's a probe response, I believe, but it's the same thing. And you're looking at a reduced neighbor report, and you're actually seeing 3 separate SSIDs that are available on channel 85, which is the primary channel, okay, that is available on 6 gigahertz. The operating class of channel 134, that is an indication of the channel size. operating class 134 translates to 160 megahertz channel. There's other values that translate to 80, 40, and 20. You also see the short SSID. That is a hash of the actual real SSID. So the radios can figure out what that is, but you can't unless you dehash it, I guess. And you can see it's housed in the same access point, co-located. You see that bit flip there. And you can also see that there's a bit that says it's whether it's the same SSID, and you see right there the value is false. So that actually goes to the earlier question. So because it's false, it's using different SSIDs. The next question I always get asked is how many SSIDs can be carried in an information element? From our testing, we've seen, at least with the chips that we use in our access points, we've seen up to 8.
That should be plenty.
Yes.
Hey guys, I do have a question while we talk about information elements. Somebody asked, will standard power and low power indoor be identified in new information elements in the packet headers, or how will this be identified for devices?
That's a good question. And to be perfectly honest with you, there's probably a good answer, but off the top of my head, I don't know it. So I will circle back and Dale, I'll provide that answer to you post-webinar.
Thanks.
But there's got to be some way to communicate that information, probably both at layer 1 and layer 2.
So we briefly touched on about the multiple BSSID coming back in the beacon frames probe responses, and then in the in-band options, we're going to briefly skip over the two that are highlighted in red, which is the fast initial link setup and the unsolicited probe response. Because after having a nice chat with David and a few other people, we kind of understand that these are probably not likely to be implemented or not implemented straight away. So we'd rather spend more premium time focusing on what we do think is going to be, well, we're pretty sure we know what's going to be the most popular in-band discovery method, which is the preferred scanning channels.
Yes. So preferred scanning channels. Okay. So I believe that's our next slide. There we go. So let me preface this a little bit. Just going back to the RNR. Okay. You need to understand that the out-of-band discovery is mandated. Okay. And if you don't use it, if you were at, most vendors hopefully will lock it down so you cannot turn it off. But if you were able to turn it off, I can promise you roaming is going to fail. As a matter of fact, if you just have a 6 gigahertz radio turned on and you are not broadcasting out a 2.4 or a 5 gigahertz SSID to allow for the out-of-band discovery to work, I promise you roaming won't work. Or they may not, your clients may not even find the 6 gigahertz. Now, that being said, there is an in-band method that is designated for optional use. But at Extreme, we're turning this on by default because we view this as kind of a backup mechanism for scanning and finding channels. And additionally, we also view this, we're seeing that a good chunk of the clients do support this, although they're not required to support this. And effectively what this is clients can still probe, but they can't probe all 59 channels. Effectively, they can probe actively every 4th 20 megahertz channel. So that'll save their battery life. And that will also allow them to do a little bit of active discovery once they're in band as well. So maybe they find out out of band, get connected to an AP on channel 5, and then they still do out of band scanning in addition to a little bit of active preferred channel channeling by probing just those channels. Now, more than likely, you're not going to be using 20 megahertz channels, but those preferred scanning channels also have to be the primary channel of any bonded channel. And if we were to look at a chart that actually showed where those primary channels are located, you will, and those PSC channels are located, they are effectively will function as the primary channel for a 40 megahertz channel, an 80 megahertz channel, or a 160. So we believe in the United States, 80 megahertz channels will be the default in most enterprises. In Europe, because there's not as much frequency space, 40 megahertz channels. You'll still be able to discover those 40 and 80 megahertz channels by scanning on these PSC channels that also function as the primary channel. I know that's a mouthful, but I view this as a backup mechanism. View this as kind of a backup to the out of band, which you absolutely have to have. And we're at Extreme, we have both of these on and locked on by default. So.
Okay, so just coming back to Europe. Well, we are in Europe with Matt, so yes, we are quite interested.
You guys are.
How is it going to work? So PSC, it pretty much, it requires you to use 80 megahertz channels, otherwise it doesn't make any sense, right? Because if you have a radio on a channel like 40 megahertz or 20 megahertz and your client just scans PSC channels, it will never ever find that radio. So we will have to rely on something else. The something else will be RNR, out of band. Can you confirm if RNR discovery, out of band discovery method, does it work currently with the access points that have been released to the market, or is it a future thing?
It has to work. It's a requirement. You can't get certified by the Wi-Fi Alliance unless you support out-of-band discovery. It's a mandated feature. And so we support it, and quite frankly, hopefully our competitors support it as well. Now, I will say this, in a lot of the early testing that I did with some consumer grade stuff, and quite frankly, even our stuff and beta stuff, didn't work at first, right? So that's what betas and alphas and stuff are for. But yeah, every AP vendor has to support. But if you turn off the 2.4 or 5 gigahertz radios, you might have a problem. Okay, I'm just warning you. So to be honest with you, the in-band scanning methods, they were meant if you were to have 6 gigahertz only radios. That's what their primary reason was, that they were defined as optional. But we view preferred scanning channels as a method, as a backup method to the primary method of out of band that every manufacturer's AP will support.
There's so much to consider now when it comes to designing for 6 gigahertz, but also when it comes to implement and configure your 6 gigahertz. But we had a poll question that we would love to find out from everyone in the audience today. And our first question is, have you started to design for 6 gigahertz networks? So have you already started to design for 6 gigahertz networks yet, or are you still waiting to do that? So we asked this question a little while ago, and we are a little bit further ahead in time now, so we'd love to kind of—
And guys, the participation in the quote is mad. It's madness. Like already more than 50% of all of you have answered that question. We are getting close to 60%, so thank you very much. I will end the poll in 5 seconds. So we've crossed 60%. I can close it anytime now. Still votes are coming. I'm closing it now, guys, if you want to vote. Yes.
The system won't let me vote, but my vote is yes.
Your vote is yes. Okay, so your vote will be 131, 132 for yes. Okay, ending poll now, guys. We have 70% of participation. You're crazy.
That is amazing.
Yep. So they are paying attention, David.
Yeah. So that's actually some really high numbers. That 23% is already doing that. I bet if we did this a year from now, those numbers flip flop. So
we accept your challenge, David, and we will do this poll again in the future, and then we'll track how many more people are designing 6 gigahertz networks in the future. But very interesting to see. Perfect. I think we've got a straight follow-up question to this poll question, Mac. And the next question is, have you started to implement 6 gigahertz networks yet? So out of you guys and girls that have started to design for 6 gigahertz, have any of you started to implement any 6 gigahertz networks yet? I mean, it's kind of a bit of a minefield with all of the stuff we've spoken so far with David around all of the considerations around what channel widths do we use, how are our client devices going to discover the 6 gigahertz networks? Are you using 80 megahertz wide channels, 40s, 20s? What are you doing? So really interested to see the results here, Mac.
And we see that just 13% of us Wi-Fi nerds are indeed implementing 6 gigahertz Wi-Fi. Is that what you expected, David?
Yes, because it's early days. Okay, this is just the beginning. But I stand by. I say this all the time. All future generations of Wi-Fi are going to be dependent on 6 gigahertz, starting with Wi-Fi 7. It actually starts with Wi-Fi 6E. and 6 gigahertz is going to drive Wi-Fi innovation for applications and drive innovations for Wi-Fi for the next 10 years and beyond. So we're in the very beginning.
Exciting times, though. Really exciting. Oh, and what is this? Something else new for us to get our heads around, David, with 6 gigahertz?
Yeah, and so this goes to the whole standard power thing and about protecting the incumbents. And this is called automated frequency coordination. You've probably heard me and others talk about this a little bit in the past. And this is still being hashed out. We expect this to be hashed out in the United States early next year and other countries to follow, but we cannot interfere with existing incumbents, even when you're with standard power APs. And basically when you deploy an AP, is they need to check in to an AFC provider database that checks in with your regulatory body to see about the availability of any particular channels for outdoor use. And so that won't interfere with the existing incumbents. So the AP will check in with its GPS coordinates, its height, its elevation, its latitude and longitude, and say, I want to use this particular channel at this particular power. And the AFC provider might say yay or nay, or might suggest other channels. And it's basically a way to get registered, and it's coordination of frequency availability. And this is nothing new. CBRS has used these capabilities for a while. The difference is this is a once a day check-in, where CBRS does it, I believe, once an hour.
They're crazy.
Yeah, and it's also more expensive. But but this technology, there are some companies that have specialized in this kind of work in the CBRS space, and will try to segue into the Wi-Fi space. And they've already mentioned this. And there's also an open source project called OpenAFC here in the United States. And there's been 8 or 9 different people that have applied to be AFC providers. And you'll be hearing more and more about who the AFC providers are. I can tell you from our end at Extreme Networks, we're hoping that you won't even see who our AFC provider is, maybe build in some redundancy. And this will start getting more and more complicated too, because the rules might be different in different countries too. But effectively, it's a check-in, and and a lot of people compare it to dynamic frequency selection, but it's really not the same thing, because this is more proactive, where DFS is more reactive, right? With DFS, if you detect radar, you have to move, right? So you don't interfere with radar. But with automated frequency coordination, you're being proactive. You're just saying, yeah, is this channel available? And I think we have a slide that actually shows an example of that. In the next slide, if I'm correct, fellas, maybe not. Yeah, there it is.
Mac's still getting used to driving for once, so he's a little bit slow. Sorry, David.
That's okay. You can go on YouTube and take courses.
That's just because of Matthew was texting me on Slack. It's his fault.
Oh, okay. Well, either that, but good job, my friend. Nice clicking. So this is Gillette Stadium, which is actually, I believe, deploys Extreme Wi-Fi. As you know, Extreme partners with a lot of sports leagues in North America, and we're actually experts at stadium Wi-Fi and for a lot of sports leagues, and we're moving into Europe as well. And we actually did a test with some AFC software. We're actually showing everything in gray is not available at all. The Uni 6 and 8 bands is not available for standard power, but 5 and 7 are. And everything indicated in green will be available for use in that stadium. And what's indicated in yellow probably will not be available due to existing incumbents. The existing incumbents, you'll probably see these fixed satellite services, especially in city centers more. It's my understanding you see a lot more of it in the United States than you do in Europe, but it all depends, and the rules might be different in different countries as well. But that's what it's all about. It's about protecting the incumbents. But just based on this little test that we did right there, you'll see that there's some channels we won't be able to use.
And hey, David, I heard there was a bit of an announcement from you guys earlier on today, wasn't there?
Well, thank you for asking, my friend. Actually, this morning, we, Extreme Networks, announced the availability for sale now of our first, the industry's first outdoor Wi-Fi 6 AP, the AP50.
Can you repeat that, please, David? Because this is something super new for everyone, I guess.
The industry's first outdoor Wi-Fi 6 AP is available for purchase right now. And we'll be shipping it in November. The AP5050, there's two models, an underseat model for stadiums, and also a directional model that can be either 30 or 70 degrees that can be mounted on walls or poles. And these are both already have 6 gigahertz radios. Now, I will preface this, these are 6 gigahertz capable right now, meaning we'll start shipping these puppies in November. Sell them to you now, ship them in November. You can actually start deploying them. But as I mentioned, the AFC rules starting in the United States probably aren't going to hit until late Q1, early Q2 of 2023. But we'll be ready. We'll be more than ready. And as soon as the AFC rules are in place, we'll light it up. You can turn on your 6 gigahertz radio. And maybe you already have it all planned out and ready to go. So we're pretty excited about that.
But guys, it's super exciting. It's like, well done, guys, that you've released the first directional antenna for 6 gigahertz. It's really amazing and exciting. But before you start deploying it, it makes sense to do a design with these directional antennas for your stadiums. And you can, of course, use the Ekahau tools to design for that beauty.
And thank you. I believe I actually sent you the antenna patterns, so I can't wait to let's get the 5050 into the Ekahau solution ASAP, guys. Get your engineering team so they can start designing it when they start deploying in November.
Yep, we
will definitely be playing around with the 6 gigahertz design with external antennas just for fun, even if I'm not doing it for a real stadium. How about you, Matt?
Absolutely, Mac. And I have to say, I've been very much enjoying all of the shaving puns in the chat about the Gillette Stadium. So they were very good and quite funny, the people that put them on there. But I think it's about time we move on to our next topic, because we've got something very interesting to talk about, which is Wi-Fi 7 or 802.11be. And what frequencies will this work on? And it's going to be supporting on 2.4, 5, and 6 gigahertz. The maximum channel width that is going to be able to support is 320 megahertz. Capable of doing 4K QAM or 4096. And then check that out, guys and girls, 46.1 gigabits maximum theoretical data rate. So I take it now we're going to need to have one switch, one internet connection per AP to be able to achieve that kind of data rate.
Yeah, so I don't know, this is a shout out for Keith Parsons, one switch per classroom. So, well, first of all, theoretical data rates, we all know that that's theoretical, right? So that would be maybe in a theoretical Faraday cage, okay? So, look, first of all, I want to preface something. There is no such thing as Wi-Fi 7 yet. It's getting a lot of marketing hype. Wi-Fi 7 is a Wi-Fi Alliance certification that's been announced, but the task group has just started work. The certification's not ready yet, and it is based on the 802.11be standard, which is not a standard yet. It's still a draft at the IEEE. Now, that being said, vendors, as you know, do put out products before certifications and standards get ratified. And also the chipset vendors like Broadcom have already announced the radios, and Qualcomm is PCA as well. So for Wi-Fi 7. Needless to say, I'm not going to give you exact dates, but it's down the road soon, okay? Now, that being said, Wi-Fi 7, in my mind, I'm cognizant to the fact of something I called update fatigue. It seems like every 3 or 4 years with Wi-Fi, we come to Wi-Fi 5, Wi-Fi 6, 6E, Wi-Fi 7, Wi-Fi 8, Wi-Fi 9, and sometimes customers get a little, fatigued with that. Wi-Fi 7, in my mind, will just continue the 6 gigahertz story. And as a matter of fact, Wi-Fi 7 is dependent on 6 gigahertz. Some of the features you have right here, like the 4K QAM and the 320 megahertz channels, Those aren't enterprise features. Those are features for one consumer grade AP at somebody's house. To me, the one enterprise feature that I believe will hold value with Wi-Fi 7 will actually leverage, once again, the fact that we have this new 6 gigahertz superhighway, and that's something called multi-link operation. So, which multi-link operation, I believe is our next slide, gentlemen, is actually, I want you to think multiple bands and multiple channels, where a Wi-Fi 7 client could talk to a Wi-Fi 7 AP and communicate at the same time on multiple bands and multiple channels. Some cases this would be synchronous, some cases asynchronous, asynchronous, and it could actually be, and honestly, I don't even think 2.4 will be used that much. It could be where you're communicating with an 80 megahertz channel on 6 gigahertz at the same time communicating with two 5 gigahertz, 40 megahertz channels on 5 gigahertz, maybe in the lower portion of 5 gigahertz and the upper portion of 5 gigahertz. Now, what's the point of all this? Well, there's actually three potential ways this could work. And the three potential ways this could work are aggregation, link steering, and also link redundancy. So, and so think of, let me talk about the two that I don't think are going to hit off right away. And that's link aggregation and link redundancy. And they have different goals in mind. But with link aggregation, what if you sent the same data on an 80 megahertz, 6 gigahertz channel, or actually some data on the 80 megahertz, 6 gigahertz channel, and then even modulated more data on a 40 megahertz, 5 gigahertz channel at the same time? Well, that's how you get these ridiculous throughput of like 46 megabits per second, right? So that crazy nonsense, right? So, but I got to tell you, while it sounds great, for that to even work, there's still something called medium contention, right? So think about it. If you're contending on 6 gigahertz and you grab the medium and you want to aggregate that at the same time with a 5 gigahertz, you might have to wait for that 5 gigahertz radio to grab the medium as well. And that wait time, the differential in wait time might actually be detrimental, So, I never believe anything until it gets field tested, right? But sounds great in theory, but that is one use case. Another use case along the same kind of lines is redundancy. So same thing, you could put in maybe a 40 megahertz channel on 6 gigahertz and another 40 megahertz channel on 5 gigahertz, absolute duplicate data. And the whole point of this is you're guaranteeing that if some of the data gets corrupted on one of the channels and one of the bands, that there's duplicate data on the other channel, and you don't have to worry, and it cuts down on your retries, right? Sounds wonderful. But once again, you have to deal with that medium contention component that may or may not play nice. To me, the one that I think we'll see, at least initially, most use is the link steering component, where maybe you have a radio that maybe a 2x2 radio client device is listening with both antennas, one on to both 5 gigahertz and 6 gigahertz at the same time, but then might steer its transmissions and its back and forth between 5 and 6 based on the RF conditions, the changing RF conditions. And this will really cut down in latency, and it will also increase reliability. And we believe that this is, in particular, will be very beneficial for applications like that depend on latency, like not only voice, but also the VR and the AR stuff that is getting a lot of hype about, but is a real thing coming down the road. So it is my mind, the link steering capabilities will probably be the thing that we see actually working, at least initially. But until we actually see this stuff, nobody knows. It's early days right now. Right now, we're talking simulations right now. But to me, this is the biggest enterprise feature. And I just want to emphasize one last thing. I get asked all the time, well, I'll just wait for Wi-Fi 7. Look, the analogy I've been using is I bought a Dodge Ram pickup truck in 2021 last year, and I love it, and absolutely love it. But then a week later, the 2022 model came out, right? So it had some new bells and whistles, but at the end of the day, my 2021 is awesome. And it's kind of the same thing. You know, everybody, I think we're getting too caught up in these generations in Wi-Fi. Moving forward, it's all about 6 gigahertz. Wi-Fi 7, yes, this is great. These new features might be great. And even beyond 8 and 9, but without 6 gigahertz, there is no value to any of this. So, so I always get asked, wait till Wi-Fi 7. And, you know, if you're due for an update, you know, just make sure you have 6 gigahertz radio in your AP. And also,
David, I especially can't wait for 320 megahertz wide channels, especially in Europe, because we have one channel that you can use for overlapping.
Yeah,
how amazing is that?
Covering all of Europe, one channel, right? It's like, wasn't there a particular vendor that used to have a single channel architecture? It's coming back. So here's my question to you guys. What about your Sidekick 2? It doesn't have Wi-Fi 7 radios in it. What is that going to mean? Are you going to be able to do Wi-Fi 7? Wow.
Yes.
Of course. Yeah, Matt, go on.
No, of course, our amazing Sidekick 2 will absolutely be able to discover Wi-Fi 7 access points and all of the readings such as like RSSI, etc. So your Sidekick 2 will definitely be able to work with Wi-Fi 7. So if you are concerned about that, don't let that put you off getting one of these amazing brand new hardware devices that can work across 2.4, 5, and 6 gigahertz, which will work with Wi-Fi 6, 6E, Wi-Fi 7, Wi-Fi 8, and beyond. You do not need to worry. This is future-proofing your Wi-Fi career.
And Dan says for you to stop showing that because he's angry. He wants to have one, I guess.
It has 6 gigahertz radios in it, so you'll be fine. And there it is. It's look how beautiful that thing is. So.
I must say it's not too bad looking, is it? So guys, if you have never heard about Sidekick 2, Sidekick 2 is our new validation device that is a new version to our still amazing Sidekick 1. It has more radios, 4 Wi-Fi radios, 9 omnidirectional, 9 antennas that all contribute to a true omnidirectional pattern. And it has spectrum analyzer that is massively faster and higher resolution than the previous one. Plus, it has USB-C. So what's not to like about the Sidekick 2? And what are we looking at now, Mr. David? What is that thing?
Yeah, so I, as you know, I write a lot of books about Wi-Fi, and here's a free one that you can download a free PDF courtesy of Extreme Networks. Just put your phone up there and scan that QR code, or just go to the Extreme Networks website, and you can download Wi-Fi 6 and 6E for Dummies and delve into it a lot more. And you know, hopefully maybe next year we're doing it again where we're talking about Wi-Fi 7 and 8 for Dummies. So, but it's our gift to you and anybody else. If you haven't read it, read it, and you can learn even more about these technologies.
Yeah, thank you very much, David. It's very thin, like for you, when it comes to the book size. It's just 100-something pages and not 1,000 that we are used to.
No, it's not like the CWNA book, which has been known to kill people if it hits you in the head. So.
Well, on the topic of keeping your phones out, if you missed it earlier, we are going to be having our annual Wi-Fi Day. It's back. You can save the world from bad Wi-Fi coming on September 15th. So you can scan the QR code or head over to ekahau.com/Wi-Fi Day. Get yourself signed up. It's going to be an awesome day of content. If you've enjoyed this content today, imagine what it's going to be like on September 15th. It's going to be fantastic. So make sure you get yourself signed up.
And since you have your phone's app, you can also scan this barcode and you can order your Sidekick 2 today. It's shipping pretty much immediately. So why not doing it? The price is pretty much the same. It's just slightly higher than Sidekick 1 was, but we have double of everything. So we are extremely proud of the value that Sidekick 2 brings to the table.
Yeah. So thank you very much, everyone, for your attendance on this webinar today. I believe we can take probably a couple of questions. If David doesn't mind hanging on for an extra few moments, we could
happy to
chuck it over to Dale to give us a question or two on topic in today's webinar.
Yeah, so here's a question. With all the talk around low latency as it pertains to 6E, is that achieved in any special way, or is it a benefit of the higher speed and spreading clients over more APs and thus less contention? Or is it enhancement?
It's, to me, a lot of it has to do with the fact, well, there's two things. Number one, you don't have the backward compatibilities problems. So you don't have all of the MAC layer overhead that you had in the legacy bands. So because of that in itself is going to increase latency, or I should say, make latency better. That being said, Wi-Fi 7 is looking to expand this even further on a couple different fronts. The link steering capabilities I mentioned with multi-link operation, we believe will enhance latency even further. And secondly, there's even talk about some enhancements to QoS mechanisms. Nothing written in stone yet that could be specific to 6 gigahertz.
Thanks. And then another question, as we talk about AFC, a lot of people are wondering, why is that delayed, and when do we think it will be approved, and when do we think we'll actually see AFC in action?
It's in flux, so it keeps getting pushed back. Okay, so I can speak to it'll be the United States first probably, and my guess is so there's a lot of people saying Q4 of this year. That's not going to happen. It's going to be 2023, first half of 2023. And that could be pushed back again. So we're waiting on the regulatory bodies to approve this, to first for both conditional and final approval of the AFC provider, locking down the rules, and then there has to be certification testing done with the AFC providers and RAPs. So that all has to happen. And then after that, then we have to wait and see what happens with the rest of the countries as well. So it's impossible for me to give you a hard date, even for the United States. It'll be a slower roll, I believe, than it has been for indoors, but it will roll.
Thanks. Well, yeah, definitely great content today. Great discussion. Hopefully everybody got a lot of value out of this. I know I did, even being one of the co-panelists here.
Yeah. So I'll just say this, guys. I know we're kind of up against the clock, but if you guys want to put together a list of questions for me offline, and maybe we can address them privately, and if you guys want to get it back to the rest of the crew, I'll be happy to answer them offline as well.
Thanks a lot, man. Really appreciate it. And David, you can start with answering, do you need multi-gigabit switches finally for Wi-Fi to support this 46 gigs?
Yeah, so look, I've been told for years that we need multi-gig. I've been hearing that for 10 years, okay? That the 1 gig uplink isn't enough. And in honesty, that just has not panned out, okay? Other than some corner cases. Now, I will say this, view it as a future-proofing thing. Okay, you don't need 10 gig uplinks, but if you want to upgrade to 2.5, then go ahead and do it. Do you need to do it right away? Probably not, but it's not going to hurt you. And now most switches have those capabilities anyway. Don't go. But the more important topic when it comes to integration with 6 gigahertz and having tri-frequency APs is PoE. You're going to need a lot more power, and you're going to need more power budget, and that's probably where you're going to be investing in your switches. 802.3 AT power is going to be a requirement for everything. And with some vendors,
so it's like 2,000 watts per AP?
Yeah, I mean, you're talking about up to 25 watt to 2,000 watts, 25 watt for AP for PoE plus. And then if you start getting the 4x4x4s, get full functionality, some vendors are going to need as much as like 40 watts, meaning you need BT power. And I will say this too, pay attention to when vendors start talking about downgrade functionality. So some vendors will tell you, oh yeah, our 4x4s will work with AT power only, or 25 watts, and you don't need BT power, but then they'll downgrade their MIMO radio chains back to a 2x2x2. So we don't do that at Extreme. We'll still give you full Wi-Fi functionality on 4x4x4 with AT power, but then we turn off like an expert Ethernet port and we turn off the USB. So it's always what you got on sacrifice. But regardless, whether it's 2x2 or 4x4, you're going to need AT power. And I'm worried about people not upgrading their power budgets. And then the number one support call that we get at Extreme, and I would be willing to bet our competitors as well, is rebooting APs due to not getting enough power. And so you really need to keep your eye on power budgets, and that's why good cloud management solutions and things like that, to keep an eye on those things is very important. So make sure you're thinking about that.
That is a huge, well, that is a hugely massive topic at the moment around power budget and cost of electricity and stuff. We're speaking to a lot of people that are scheduling access point radios to be disabled, or access points to be completely shut down, not during business hours, to try and save as much money as possible when it comes to that power consumption. So it's a huge thing that we need to think about, especially with the way things are right now. And yeah, I'm sure Extreme.
You're seeing a lot of green initiatives in IT and networking companies. I know we have one going on in Extreme right now for exactly what you just spoke about, is like, how can we save energy during off hours and other creative ways using technology to conserve energy. So I think you'll see innovation in the future from all vendors, and especially there's a big push for this, especially in Europe, by the way. So so it's very important.
Massively. Well, David, I just want to say a huge thank you for joining us on the webinar today. It's been amazing content. I have loved every second of it. I can see with how many people we've still got stayed on over the hour on this webinar. People were just loving the content today. So thank you so much, everybody, for joining us and staying over with us. And we hope that you enjoyed getting a bit of an insight into the 6 gigahertz Wi-Fi and beyond. And just a huge thank you to everybody on the call today.
Thank you very much, guys.
Pleasure.
It was an honor to have all of you.
Thanks.
Absolutely my pleasure. And I want to say congratulations to Ekahau on your sidekick too, as well as bringing 6 gigahertz into your other solutions. So great work, gentlemen.
Thank you.
Yeah. Thank you very much, everybody. And we will see you on the next one.
Bye, everybody.
Take care, guys.
Thank
Bye.
you.